Yes, good afternoon, everyone. Myself, Stalin, Assistant Professor in the Department of Mechanical and Automation Engineering, PSN College of Engineering and Technology, Tirunelveli. Now, we are going to discuss about the engineering materials and metallurgy. First thing, what is engineering materials? The materials maximum used in the different field of engineering called the engineering materials. That is, it is a substance which are useful in the field of engineering are called the engineering materials. That materials made up of the matters, different matters. Materials are anything that have weight and occupy some space. So each and every metal is having some different weight and different space occupying. The field of engineering is concerned with the optimum use of material. Commonly, the engineering materials are classified as two different types. One thing metals, and another one thing non-metals. First thing, the metallic materials can be broadly classified as the two types. One is ferrous metals and another one is non-ferrous metal. Okay. Similarly, the non-metallic materials can broadly be classified as different categories like plastics, ceramics and diamonds, composites and nanomaterials. First thing, what are metals? The metals mean nothing but it's a elemental substances. It is a solid materials which is typically very hard, shiny, malleable, fusible and ductile with a good electrical and thermal conductivity. For example, the metals like the iron, gold, silver, aluminum, copper, bronze, brass, etc., such as the steel. So these metal can be divided into mainly two groups. One is ferrous group and another one is non-ferrous group. So ferrous metal group is nothing but in any metal that is primarily composed of iron has magnetic properties. A ferrous metal is known as for its hardness, durability and tensile strength. Some common ferrous metal include alloy steel. So the difference between the ferrous and non-ferrous metal is nothing but based on the compositions of the iron, whether it's primary or secondary. So that is the ferrous material. Important ferrous metals for the present purpose are the cast iron, wrought iron, steel. Then, okay. So first thing, what is cast iron? Basically, we are using maximum is in the cast iron. So in an alloy of iron that contains 2 to 4 percentage of the carbon contents along with the varying amount of silicon and manganese and traces of the impurities such as sulfur and phosphorus etc. It is made by reducing iron ore in a blast furnaces. Most cast iron is either so-called grey iron or white iron, the color shown by the fracture. You can easily analyze the color to what are the difference between the iron or white iron, grey iron, like that. So here types of cast iron, there are different types. Various types of cast irons are produced using different heat treatment and processing techniques including. These types of irons we discussed based on the different heat treatment at different processes like that. So first thing, grey iron, white iron, malleable iron, wrought iron and compacted graphite iron. So these different iron contains different percentage of the carbon contents. So like that. The first thing, what is grey iron? Is a type of the cast iron that has a graphitic microstructure. It is the name of the gray color of the fracture it forms, which is due to the presence of graphite. It is the most common cast iron and more widely used cast iron based on weight. So, grey iron is nothing but the presence of maximum the graphite material and it visualizes the grey color when it fractures the material. And the carbon content of the grey iron is 3 to 3.5% of carbon here. It is mainly in the form of graphite. This type of cast iron is inexpensive and has high compressive strength when compared to the other cast irons like wrought iron or steels, whatever it is. So it has low tensile strength and low ductility. The number of indicates the ultimate tensile strength in megapascal and 15 indicates 0.515 percentage. Again, the white cast iron. In this cast iron, carbon is present in the form of iron carbide that is Fe3C, which is hardened material. brittle material. So it is very tough material when compared to the gray iron. White cast iron has high tensile and low compression. The presence of iron carbide increase hardness and make it difficult to machines. It contains 2 to 5% of the carbon contains present. And the applications of white cast iron is nothing but it's mainly used to create car wheels or rolls for crushing machine and jaw crusher plate, etc. like that. So this is the white cast iron. So next one, malleable iron. Malleable iron is the main one of the cast iron. These are white cast iron rendered malleable by annealing process. It is very tougher than the grey cast iron and they have excellent machining properties. So we can machine easily. So it can withstand more strength like that. So this is next. This is the application. It is used for making parts where forging is expensive, such as hub for wagon wheels and brake support. So nowadays, a lot of forging operations making into the malleable iron material. So it has very high strength like that. So it is the very excellent machining properties also. So only we have selected this material in forging process. Next thing, wrought iron. It is the very pure iron material, but it contains that is 99.5 percentage. It produces re-melting pig iron and small amount of silicon sulfur may be present. That is 0.5 level percentage of the other materials. It is very tough, malleable and ductile. It can be easily forged or welded when compared to the cast iron or grey iron. So next thing, applications of the wrought iron. It is maximum, it's mostly used to create the chain, the crane hooks and the railway couplings, so etc. Because it has more corrosion resistant materials also like that. So when compared to the other cast iron. Next thing, there's steel. Steel is the nothing but the alloy of iron and carbon, in which the carbon content range up to 2%. So, okay, so steel is the best corrosion resistant material. So with a higher carbon content, the material is different is the cast iron. Okay, by far the most widely used material for building the world infrastructures and industries. It is used to fabricate everything for saving needles to oil tanker. So maximum this properties is this is a very stronger, very tougher material as well as the very corrosion resistant also. Next thing, it composed simply of iron and carbon accounts for 90% of steel production. So nowadays, the carbon's content, that is steel manufacturing, is very high compared to the other ions like cast ions or mild steels, whatever it's. So low alloy steel is alloyed with the other elements, usually molybdenum, manganese, chromium, or nickel in amount of up to 10%. Way to improve the order of the thickness. Then applications of steel. The major applications of steel is mostly used to in buildings for infrastructures, mechanical equipments like testing, improvement experiments like that. Then automotive, metal products, other transport, domestic appliances, electrical equipment, whatever it's. Okay, for example, mechanical equipment is nothing but, for example, take the vernier caliper. So that's the metal, it's the steel. In automotive, mean we can say stop it, sir.
Stop it. Explain.
Example மாத்திட்டேன்.
Yes, sir.
Example மாத்திட்டேன், அதனால ஸ்டாப் பண்ணிட்டேன்.
Okay. Space plus, sir. So now, sir, cuma sir time buat coba ya pakai experience ini namanya. Time is for time connection namanya tadi sir.
So the automotive example is nothing but the, for example, if you take an on two-wheeler bike, so the silencer materials will be made by the steel. So that is metal product and the other transport domestic appliances. Domestic appliances mean nothing but we can take on needle. So like that. Then electrical equipments from point F3. So electrical equipments like the sockets, then plug point, so like that. So this is the applications of steel. Next, the categories of steel is nothing but mainly two categories of steel. One is plain carbon steel and another one is alloy steel. So plain carbon steel is nothing but there are different combinations of the carbon contents present in the steel. Again, it is a metal alloy. It is a combination of two elements. One is iron and carbon. So other elements are present in the quantity is too small to affect its properties. The only other elements allowed in the plain carbon steel, manganese is 1.65% and silicon 0.60 and copper 0.60. So mainly there are two different materials, like one is iron and another one is carbon. The carbon steel is divided into three subgroups. The plain carbon steel divided into three subgroups. One is low carbon steel, medium carbon steel, and high carbon steel. These the difference of the presence and the combination of the carbon percentages. This is the difference. First thing, low carbon steel. So low carbon steel is the type one of the plain carbon steel that has small carbon content, typically in the range of 0.05% to 0.3%. Its maximum reduce the carbon content, make more malleable and tactile than other steel types. Like low carbon steel is called known as mild steel. Then applications of the mild steel is nothing but which is used in automobile body. Then automobile that's component. Then structural shape of like I-beam or channels and any angles in ferrous or non-ferrous like that. Then pipelines, then construction and bridge components and food cans. So fully made up of the low carbon steel. Again, the medium carbon steel. It's also one of the just increase the carbon level from low carbon steel. So it is similar to low carbon steel except that they contain carbon from 0.30 to 0.60 percentage and manganese from 0.60 to 1.65. These steels are mainly used for making the shaft, axle, gear, crankshaft coupling and forging. So this kind of materials maximum used in the engine parts. So in the applications in the automobile areas. So it is used for making shaft, axle, gear, crankshaft coupling and forging. Steels with a carbon dating of 0.40 to 0.60 are used for the rails, railway wheels and rails, etc. So next thing, high carbon steel. This is the high carbon steels or steels with the high. It has a reduced ductility, toughness, and buildability. It has carbon content of 0.60 to 1.25 weight percentage. The manganese content is it's very low compared to the carbon, and it has the high hardness and the high toughness of the material when compared to the low carbon and the medium carbon material. Next, the applications of the high carbon steel. It is used in transmissions line and microwave towers where related light members are joined by the welding. The transmissions lines mean nothing but the electricity line. The wire is made up of the high carbon steel, and again the microwave tower also made in high carbon steel. So we can't join the process because it does not build a good buildability material. So we can only join by welding. This is the high carbon steel. Next, alloy steel. What is alloy? The combination of two or more metals is called an alloy, right? So alloy steel is steel basically that is alloyed with a variety of elements. There are number of elements between 1.0% to 50% by way to improve the mechanical. So why should we create the alloy? What is the purpose mean? We have to improve the properties. Okay, for example, already the aluminum, we've taken aluminum, already aluminum is present. It is a natural material also, but it has tensile strength very low when other compared to the steel like that. So we want to improve the shelf mean we can make some alloy with the help of different materials like aluminum, like zinc or copper, whatever it's. So alloy steels are made of iron, carbon, and other different elements such as vanadium, silicon, nickel, manganese, copper, and chromium. When other element comprising metals and non-metals are added to carbon steel, alloying steel is formed. So, alloy is the best materials in traditional because the conventionally the materials have different properties. Okay, so only we have created the alloy steel. Next, types of alloy steels. There are different types of alloy steel: low alloy steel, high steel alloy steel, high alloy steel, stainless steel, micro alloy steel, the advanced high strength steel, margin steel, and tool steel. These different types of alloy steels using in different applications. For example, if you take a stainless steel means in our home appliances, these are vessels, the stainless steel. Then operation equipments also, medical equipments also stainless steel. So like that, the different types of steels are used in different applications. So next one, the non-ferrous metal. Non-ferrous metal means nothing but the without the presence of the iron. That is called a non-ferrous material. These materials contain the different percentage of their materials like aluminum or copper, lead, but the absence of ferrous material. So the definition of non-ferrous metals are those that do not contain iron. So like these pure precious metal. So this is a precious metal. We can create naturally. Okay. So it includes aluminum, copper, lead, nickel, tin, titanium, and zinc, as well as copper alloys like brass and bronze. A list of ferrous metals contains iron and its alloys, including hard steels. The mechanical properties of non-ferrous like steel make for strong load-bearing wheels. So the difference between the ferrous and non-ferrous means the ferrous materials maximum strength when compared to the non-ferrous, but weight-wise it's a very better than the very better to a non-ferrous. But corrosion resistance in happened in the ferrous, but non-ferrous metals does not. It's a best corrosion resistant materials like that. So next, the non-ferrous metal like aluminum, copper, lead, nickel, tin. First one, aluminum. So what is aluminum? It is one of the metal. It is one of the non-ferrous metal. Okay, aluminum is a silvery white and lightweight metal. It is very soft and malleable when compared to the iron or other steels or alloy like that. So uses the aluminum is used in a huge variety of products, including cans, foil, kitchen utensils, windows, frames, beer kegs, and aeroplane parts. This is because of its particular properties. Okay, so maximum we can use aluminum in every area like transportation, appliance mean aeroplanes like that. So tin can and foils, kitchens and stuff, window frames. So like because of it is a well corrosion resistant material. So only we have selected this material. Again, nowadays there are some researchers to improve their shelf by using the aluminum alloy. Next, the useful applications of aluminum in modern society. Power lines, high-rise building, window frames, consumer electronics, household and industrial applications. Power lines means the electricity wire. We can use in the aluminum wire. Then high-rise buildings, the window frames, consumer electronics, household like that. Next thing, the copper. It is one of the non-ferrous material which is very strong material in the non-ferrous materials compared to the aluminum whatever. Okay, tin is like that. So the copper material is a soft. First thing is a soft, the malleable, you can machine and a ductile metal with a very high thermal. So we can easily bend the copper material compared to the alloy that is cast iron or whatever it is. Okay, so it is a very good ductile material with a high thermal conductivity and electrical conductivity. So nowadays we can use the materials in our electrical wires. So it's a because of it is very good electrical conductive material in our society. So we can select easily. A freshly exposed surface of pure copper as pinkish orange color. So we can see the copper color like pinkish orange color. So we can easily identify which one is the copper, which one is the aluminum. But both are in same condition, like the soft. Soft means just density is very same for aluminum and copper, but we can easily analyze the different color. For aluminum is white color, for copper is pinkish orange. So the copper is used as the conductor of heat and electricity. It is a very good conductor, like as a building material and as a constant of various metal alloys such as sterling silver used in jewelry, copper nickel used to make marine hardware and coins and constant used in stone because it has a very good corrosion resistance. So we can use a lot of times in our alive. Okay. Next, using strain rods and thermocouples for temperature measure, as well as it can withstand more heat. So it does not change the characters when they got more temperature when compared to the aluminum. So this is a high melting point when compared to the aluminum or tin. So iron, so like that. So this is the application. Applications it is used in maximum cooking and tensile spark plug, electrical wiring, cable, and bus boards. So like that. So copper is a very good material, very good soft materials, and very good high strength and ductile material. We can modify, we can change the shape suddenly with the help of different machining. So that is the ductile. So next thing, what is plastics? No, plastics are the group of material. It's one of the material, but non-metallic material. Okay. So either synthetic or naturally occurring that may be shaped when soft and then hardened to retain the given shape. Plastics are polymer. A polymer is substance made of many repeating units. Okay, so plastic materials is one of the polymer materials based metals. So these plastics are classified into two types. One is thermoplastic and another one is thermostatic plastic. Thermoplastic is nothing but we can reuse or remold the thermoplastic, but we can't remold the materials. That is called a thermostatic plastic. So thermoplastics materials like the rubber, nylon, polymer, so like the thermostatic plastic also, polyvinyl chloride, that is PVC. So this is the difference between the thermoplastic and the thermostatic plastic. Again, thermostatic plastic is very strong than the thermoplastic. Again, it has very high melting point also compared to the thermoplastic. This is the application. Plastic is used across almost every sector into the produce packaging in building and construction, in textile, consumer product, transportation, electronic and industrial machinery. Yeah, we know already the plastic is maximum using in our society. Okay, so where it will used to produce the packaging the food, in building and construction equipments, in textile equipments, the hanger, consumer product transportation, the two-wheeler bikes, or by electric anything. So electric and electronic equipments that like motherboard, so electrical switches, so industrial machineries, the case of the machines, so like that. So these all applications are maximum used in the plastic, that is thermoplastic or thermostatic plastic. Next thing, the ceramic. A ceramic is a natural material. It is neither metallic nor organic. Ceramics are typically hard and chemically non-reactive, can be formed with heat. So ceramic is the very good heat conductivity material. It can be withstand more heat compared to the other materials. So ceramics are more than pottery and dishes by using the clay, bricks, tiles, glass, and cement are probably the best known example. So nowadays in our home usual things or any organization, we can make some roof by using the tiles. Okay, then glasses, then bricks, the clay, the cement, so like that. So types of ceramics mean there are three different types: earthenware, stoneware, and porcelain. So this is the different types of ceramics created in different things to the percentage of natural things. Then composite materials. So what is composite materials? It is the artificial material. It's maximum made by manual thing. Okay, composite materials are formed by the combinations of two or more materials with a different properties. So it without dissolving or blending them into each other. Example include concrete, mud bricks, and fiberglass. So why should we prefer composite materials? We want to improve their shelf, whatever it's like metallic materials or non-metallic materials or polymer or ceramic-based material, anything will help. So we want to improve their shelf. So only we have to select it and to create something by using the composite process. So the types of
So the last slide is there. What is the last slide? You know, because what is 5 minutes to hide? Or 5 minutes to the slide of check this.
no set there go.
And the guy who just tank is right.
Check.
Then you know the ceramics to composite materials come from the experience of money from the with money is very straight. And 26
26.
3 1 at the 25 at the 30 minutes ago, which நமக்கு comfortable இருக்கும் 30 minutes மேல போயிட்டு நமக்கு எந்த பிரச்சனை கிடையாது ரீடைல் சொல்லுவாங்க சரி பாஸ் ஸ்பேஸ் பாக்கெட் பண்ணிக்கலாம்
சரியா
and pass ஸ்பேஸ்
okay, so the composite there are three different types. One is the metal matrix composite, polymer composite, ceramic composite. So what is metal matrix and what is polymer and what is ceramics? Nothing but the metal matrix composite, the combination of two or more metallic materials. So two or more metallic materials of a metal based composites is called metal matrix. The polymer based matrix means the plastics like this, the plastics. So that is the polymer, the polyvinyl chloride. So like that. So ceramics means the natural sand or clay. So whatever. So this is the types of metal matrix. So how can we prepare the composite materials? So what are the processes we need? That's mean, for example, if you take a metal matrix composites, means that first thing we want to select the two or more different materials. So with the percentage of different percentages. So first thing we have the selected, as well as we have taken the materials. Okay, we want to first cast the materials for bonding the substances. So for example, we have selected one aluminum and one zinc main. So with the different percentages. Okay, so again it has some different melting point. For example, aluminum the difference and zinc also different. So we want to preheat the material first thing and goes to the casting process with the maximum percentage melting temperature point. So that is the after sometimes the metal will be melted and collide with one by one the atoms level, the micro atoms also bonded. So the materials surely will change their own properties from conventional to traditional. Again, the polymer matrix. Polymer matrix means nothing but plastics or glass fiber or resins. So like that. So it's made up of the different methods by hand or machines. So how to fabricate maximum? For example, if you want one plate, make one plate mean there are 2 or 3 different fibers they have available. So first thing we should keep the fibers and again to pour some resin on surface of the sheet again to keep the fibers. So again one by one step. So what's the procedure and what are the contents we need first thing. So that is the polymer matrix composite. So what is ceramic composites? Means nothing but the ceramic composites means the white clay or sand, the bricks based materials. So this is the ceramic matrix. So ceramic materials like the tiles, the wash basin, the sanitaries, like that. Okay, this is the so except these composite materials are available. It's the natural fiber composite. So like that. So natural composite is nothing but the we have taken the different wooden pieces or leaf or root, stem, whatever it is. Okay, so we have to made by using these things. So that is called natural composites. So composite materials is the advanced technical one thing. When it's one is the traditional. When the conventional is the property is very low, man, we can alter, we can change, we can make, we can improve the properties. So that is the composite material.